Okay, so to illustrate this week's various programming topics, we're going to create a Celsius to Fahrenheit converter. So our program will ask the user for the current temperature in Celsius. We will then convert it to Fahrenheit and display that conversion using a nicely formatted output using aligned columns and such. So one of the things that trips people up in programming when they're first starting out is understanding that the statements we write are not defining relationships between entities. They are statements that execute one after the other in a determined order. So I'll explain what that means as we go along, but just keep in mind that's kind of the key point that you need to remember about this week. It is the number one thing that trips people up starting out with programming. So first, let's put a little comment in here just to remind us of the formula we're going to be using. So Fahrenheit is going to be equal to Celsius times 9/5 plus 32. I believe that's the correct formula for converting from Celsius to Fahrenheit. So to start out, we're just going to create a very slimmed down version of the program. So this is a general programming practice. Rather than trying to build the whole thing at once, we build a small piece, get that piece working, build the next piece, get that working, etc. And then eventually we have the whole program. So to start, I'm going to create a variable to hold our Celsius value. Now, eventually we're going to get this from the user, but for right now, I'm just going to type it in as a constant. And when we create a variable, as you saw in the book, you need three things. You need what kind of variable it is, what the name of the variable is, and what value it has. So in this case, we're going to use a float, and I'm going to call our variable Celsius. Actually, we'll just call it C, so it'll match up with our equation. And then for right now, I'm just going to say that it is 30 degrees. Now, if you notice here, I get this little error because by default, constant numbers with decimals are considered doubles. So I have to put a little F here if I want the computer to recognize, the compiler rather, to recognize that that's a float. Now you don't have this problem if you specify a whole value. It'll just convert this integer into a float for you. But if you do specify a decimal value, even if it's just 0.0, it thinks it's a double. You can't stick a double into a float because, as you saw from the reading, a double precision decimal number is larger than a floating point number. And so we have to put a little F there. All right, so now let's do our calculation. So to convert it to Fahrenheit, we're going to take our Celsius value, we're going to multiply it by 9, divide it by 5, and then add 32. Now, one thing to watch out for, let me just put some comment markers here. We're going to ignore that code for a second. I just want to show you something. So let's say we have an integer x and it's equal to 5. And I decide I am going to do some division. So I'm going to say, and I want to just print out the result here. Console write line. 5 divided by 2 is what? And so what I'm going to do here is print out the result that I get by taking x and dividing it by 2. Okay. Now this is just string concatenation. I'm just taking the x value, dividing it by 2, and putting it here so that we can see that result. So when I run this, you'll see that if I divide 5 by 2, I get 2. Now this is not the answer you would expect. If instead I change this to say 5 divided by 2.0 and I run that, you'll see that the answer is 2.5. And that's because most programming languages, if you divide by an integer, and so if I don't put a 0.0 or an F here to indicate that it's either a double or a float, by default, numbers are integers. So if I divide by an integer, then the answer will always be truncated, which means the decimal part will just be thrown away. It's not rounded, it's just truncated. So instead of 2.5, I just get 2. If I want the exact answer, and I know that it's got to have a decimal part, then I need to make sure that either I call this a float by putting an F there, or I make it a double by using a decimal point. Okay? So either one of those will give me the exact answer. So this is called integer division, and most programming languages suffer from this problem. It's not so much a problem. It's a design. It's a performance optimization that we use in some cases, but it can trip people up. So just remember, if you're dividing, you want to make sure to always divide by a float or a double. So we'll go ahead and switch back here. I will take these comment markers out. And now I'm going to correct our problem by changing this to be a float. Also notice here, if I try to do this division without making it a float, again, we have a problem because since it's a double, it says, hey, I can't divide floats by doubles because doubles are so much more precise. And so something bad's going to happen. We're going to lose precision. So I'll just mark this as a float. Alternatively, if I don't want to deal with that, I can change all of my variable types to double. Get rid of all those F's. Everything is a double. The downside of this is that doubles take up more space. And so if you have a program that's doing a lot of calculations and storing all that information in memory, it'll take up more memory, more RAM, sometimes more processing speed to deal with doubles than it does with floats. So generally, if we can get away with it, we will just use a float. But we just have to remember to mark our values accordingly. Okay. All right. So coming back to this, we now have our Fahrenheit calculation defined. So let's go ahead and print out that result. So I'm going to say console right line. The answer is, and then we'll use our interpolation syntax here. And if you saw in the book, there are a couple ways to do this. And I'm going to, rather than doing it the long way, I'm just going to put this here. Now, you'll notice that if I run this like this, it's not going to work. The answer is F, because we have to put a $sign at the front of this string in order to make this variable interpolation work the way we expect. So now it'll say the answer is 86. So the question is that correct? If I take Celsius at 30 degrees and then convert it to Fahrenheit, is it in fact 86? So we'll just bring up Google here and see that if we bring up 30 degrees, we do in fact get 86 Fahrenheit. And just to make sure that that conversion is correct, if I do it at 32 degrees, you'll see it should be 89.6. So let's change that to 32, run that, and we do in fact get 89.6. Okay. Now, this is the very bare bones version of our program. We want to make a few adjustments to it. So first of all, we don't want to be stuck with a single value. We want the user to be able to type something in. So what we'll do is we will first print out a little prompt here for the user to be able to enter a value. And we'll say enter a temperature in Celsius. And then we will capture that value. Now, when we use the readline command from console, we don't get a number type, we get a string type. And so we have to make sure that we convert that into a float before we use it. So first, we'll just type, this is what the user input to this read line here. Now, we're going to ignore this little squiggle here for now. We'll come back and talk about that another time. But if I want to use this, I will say float equals user input. Now, as your book mentioned, there are a bunch of different ways you can convert things. You can use the convert class, and there are some differences between convert and parse. The book talks about speed performance. That's really not the most important difference, but we are going to ignore all the differences for right now. And we're going to say we want to convert to a single. Single precision is the other name for float. So we're going to say convert to single. We could also use convert to double. We could use convert to decimal if we're using the decimal type for currency, which is something you'll use in your assignment. But in our case, we're going to use convert to single. And we're going to say this is the value we want to convert. Okay. And so now we have our new definition of Celsius here. And so we'll get rid of that line. And so just to review, we are now printing out what we want the user to type. We're then capturing what they type and storing it in this variable called user input. That's a string variable. So to use it in our calculations, we have to convert it to a float or in other words, a single precision floating point number. And so we use the convert to single command. And the result of this conversion is stored in our C variable. And then we're going to use this variable just like we did before, and then print the result. So when we run this, enter a temperature in Celsius, and we'll say 32. And the answer is 89.6, just as we expected. Now, there are a couple of things I want to point out before we go any further. I talked about how we are defining not a relationship, but doing a one-time calculation. So let's say I come down here and I change C to be 100 degrees Celsius. Okay, so if I run this program, I type enter a temperature in C, and I type 32. Okay, now at this point, I'm capturing the 32, but then down here, I'm changing what Celsius is to 100 before I print the result, okay? But notice that that does not change my Fahrenheit calculation. And this is what sometimes people get confused by. I am not creating a relationship between Celsius and Fahrenheit here. I'm doing a one-time calculation between what is the current value of C and what will then become the value of F. So I'm converting this here to F. If I change C afterwards, it doesn't affect what gets printed because I've already made that conversion. Okay. So if you want to kind of see this in action, actually, let me put that back. I'm going to use breakpoints. We talked about breakpoints previously. So we'll put a breakpoint in our margin here. Okay, so what we'll do is we'll step through this one by one, and down here it'll show me a list of all the variables in my program and the current values. If you don't see those, make sure that you don't have autos selected, select locals, and it'll show you all the variables. So user input, C and F are the three different variables I have in the program. User input starts out empty, which in programming we call null. C and F default to having a value of 0. So I'm going to execute this first line, and it prints out my message here. And then we move on to line 12. I'm going to execute that. And then it's waiting for me to type something in. So I'll type in 32. Press enter. You can see that now user input has a value of 32. It's a string though, so it's wrapped in quotes. You can see whenever a variable changes, it will be read in this display. Okay, so next I'm going to do the conversion, converting the user input variable into a float. And so you can see that now our Celsius variable, our C variable, has a value of 32. I'm going to then execute this line. And so our F variable is now 89.6. And this is the part where sometimes people get confused. So on this line, I'm going to set C equal to 100. But notice that that only affects the C variable, does not affect the F variable, does not affect our Fahrenheit, because when we executed line 15, that was a one-time conversion, not a relationship. And so changing the value afterwards doesn't affect anything. And so then we go to the final line, and it prints out our result. Okay. So I'll disable that breakpoint. And we'll move on with the rest of our project. So get rid of this line because we don't need that. All right, so right now, when we prompt the user for our temperature, we prompt the user and then they enter the information on a separate line. We can fix that by changing from write line to just write. And so write line will print out our string and then put a new line underneath it, whereas write will just print out our string and not do anything extra. So now if I run the program, you can see that I'm prompted on the same line as I have my instructional page here. Okay. All right, so one more thing I'm going to do just to make my life a little bit easier. I've got all these console reads and console writes. So we can take a little shortcut here. We can say using static system console up here at the top. And then I don't have to type console every time I want to write or read from the console. Some people don't like to do that. They like it to be more explicit, but whatever works best for you. All right, so notice how I've got this broken up also into sections with these blank lines. So this is the section where I'm getting the Celsius value. This is the section where I do the calculations, and this is the section where I display the results. The computer doesn't care. I could write it all like this. In fact, I could write it all like this. I could just put all of these statements on a single line. As long as I've got those semicolons there, everything would work and it would run just like it does previously. But it's a lot harder to read. And so instead of doing that, and instead of bunching it all up, you should think about your English composition class and how you break paragraphs up into unique ideas. And so in programming, we will do that as well. We will have a clump of code, a paragraph essentially of code that all belongs to the same idea. Get the Celsius value, make the calculation, display the result. Okay, that will become important later when we start building more complicated programs and start writing functions of our own. All right, so the last thing I want to do is change our output. Right now it just says the answer is 89.6, which is kind of a dumb thing to say. And so we're going to change that. So I think what we want to do is we will first, let's print out a fancy header like this. And we'll say right line. Now, for this part, we will say, we'll put our little format $sign on the outside so we can use format strings. And we'll say that C degrees Celsius, and then we'll write F degrees Fahrenheit, that. And we'll just go ahead and put this little header, our little heading line there at the bottom. Now we'll run that and we'll enter our number, and let's get rid of this other line here. But we can see that we've got a little bit closer to nice output, 32 degrees C, 89.6 degrees F. But one problem is we don't have these lined up. And so we're going to use our alignment and formatting specifiers here. So first of all, I want to right align these numbers into a column, let's say that's 3 spaces or 5 spaces wide. And so to do that, next to the variable inside these braces, as you hopefully saw from the reading, we are going to just put comma 5. This is how wide we want that column to be. And so when I run that, and we type 32, now we see that these are lined up in a column that is 1, 2, 3, 4, 5 spaces wide. 1, 2, 3, 4, 5. And we can make that column with whatever we want. I chose 5 because that lets us use 3-digit numbers plus a decimal. Now, speaking of decimals, it would be nice if, even though we don't type a decimal here, if we always showed the same number of decimals in our output. So we can add that on as well. We can say that we want to use a format of floating point, and we always want to use 1 decimal. We'll add that to both of those. So when I do that and run that code, now we can see that everything lines up just right. So to review, we started our program. I put a little comment here describing exactly what I wanted to do. This helps me later on when I'm writing the code. We got the user input by first using write to put out a prompt onto the console, and then we used readline to get the user input, and readline always gives us a string of characters. Even if they're only typing numbers, the type of data we get back is a string. Since we're doing a math calculation, we need to convert that string into a number. In our case, we want to use floating point numbers, which are also referred to as single precision floats. And so we use convert.toSingle in order to convert that string into a float, which is then stored in the C variable. We then create another variable called f, and we write our calculation here where we take Celsius, multiply it by 9/5, or multiply it by 9 and divide it by 5. And we talked about how we can't just write the number 5 when we're doing division because it will get rid of any decimals. So instead, we have to make sure we're using a float here as well. And we did that by specifying the letter F. And then we add 32. We store the result here, and then we print out our output. And we're using our format shorthand, our string.format shorthand using the dollar signs. Inside the curly braces, we have what exactly we are printing. This is called string interpolation. So we have a string and we are interpolating or inserting another value. In this case, the value that's stored in the C variable. We are aligning that in a column 5 spaces wide, and we are formatting it as a decimal number or floating point number with one decimal point, with one decimal place rather. Okay, and then we do the same thing with Fahrenheit, and then we print this at the bottom. So that covers, I believe, all of the concepts you need to go over in order to do this week's assignment. All right, so for this assignment, you're going to be creating a simple bill calculator that's used, for example, in a restaurant. You'll be prompting the user for the subtotal amount, using a fixed value of 6% to calculate the tax, asking them for the tip amount. You will then be printing the subtotal, the tax, the total after you add the tax, the amount for the tip, and then the grand total at the bottom. Now, this seems like a lot of steps, and it is. So you want to make sure you break this down into small parts, solve each part, and then put it all together. So part 1, get the user to type in the subtotal amount. Make sure you store that in the proper type of variable. Make sure you convert it to the type of variable you need for calculations with money. Then ask the user for the tip amount for, and then you're going to display, notice that you're not displaying 21 here, you're displaying, here is my subtotal. I've added tax to it already, so before you print this, you'll calculate the tax. Then you'll add that to the subtotal, and you'll display that as part of this prompt. The user will type in a number. That's your tip percentage. But in order to get this to be a percentage, we have to divide it by 100. So behind the scenes, you'll divide this by 100 after you have converted it to the proper data type to do that. Then you'll start printing things out. You say, okay, I've got the subtotal, I've got the tax percentage, I've got that total. All of this information you'll have had up to this point. You then have calculated the tip, and then you calculate the grand total and print all of that out. So again, take it one step at a time, get each little part working. You can print out just part of the receipt, and then you can worry about the formatting at the end. Make sure that you get the formatting right. The expectation is it will match this format with these column widths. So make sure you figure out the exact width of these columns based on the length of this line. And if you have questions, ask on Slack or email, but preferably on Slack.